Hello kids, welcome to Learner's Planet. Kids, this is our second session for factors and multiples. I hope you might have revised the previous session and you'll be clear about the concepts of factors and multiples. Just for a recap, let's do 2-3 more examples of factors and multiples. Okay, let's write first 5 factors of number 56. Okay, definitely 1 will always be there. Then 56 is divisible by 2, so 2 will be a factor. 56 is not divisible by 3, that means 56 is not coming in the table of 3. Then 4, then 5 will not be there, 6 will not be there. 7 8s are 56, that means 7 is factor of 56. Then 7 8s are 56, that means 8 will also be factor of 56. So we have written down the first 5 factors of 56. Apart from that, we can write down the remaining factors also. So it's 14, then 28, then 56 itself. So in all there are 1, 2, 3, 4, 5, 6, 7, 8 factors are there of 56. Okay, and if we are asked the first 5 factors, then it will be 1, 2, 4, 7 and 8. Okay. Now let's find out the first 5 factors of number 60. Okay, so 1 will always be there. Then 2 into 30 is 60. So the next factor is 2. Then 3 into 20 is 60. That means 3 will also be a factor. Then 4 into 15 is 60. That means 4 will also be a factor. Then 5 into 12 is 60. That means 5 will also be a factor. So first 5 factors are 1, 2, 3, 4 and 5. Now let's find out the remaining factors also. It's 6 into 10 is equal to 60. So 6 will also be a factor. Then the remaining factors are 10, 12, 15, 20, 30 and 60 itself. Okay, I just write down over here. It's 10, 12, 15, 20, 30 and 60. So if you are asked about the first 3 factors, you will write down 1, 2 and 3. And if you are asked the first 4 factors, then 1, 2, 3, 4 will be there. If you are asked about first 5 factors, then 1, 2, 3, 4, 5 will be there. Okay, let's do 1 or 2 more problems. Okay, in the same question, if I ask what is the smallest factor of 60, can you answer it? The smallest factor of 60 is 1. And what is the biggest factor of 60? That is number 60. And how many factors are there of 60? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are 12 factors. So various questions are asked about the factors. So you should be conceptually clear about the term. Okay. So in this question, 1 is the smallest factor, 60 is the biggest factor, and in all there are 12 factors of 60. Okay. Let's take one more example. Now let's write down the factors of number 54. Okay, so 1 will obviously be there. Then 2 into 27 is 54. That means 2 is also a factor. Then 3 into 18 is 54. Then 3 will also be a factor. Then 6 into 9 is 54. That means 6 will also be a factor, and then 9 will also be a factor. Then 18 will be a factor, and 27 will be a factor, and the last factor will be 54. So I just write down over here. So it's 18, 27 and 54. Okay. Now the first question is, how many factors are there of 54? It's 1, 2, 3, 4, 5, 6, 7, 8. 8 factors. Which is the smallest factor? That is number 1. Which is the greatest factor? That is 54. Okay. And what are the first 3 factors? Which are 1, 2 and 3. Now you can be asked, what are the first 3 factors except 1? What are the first 3 factors except 1? So except 1 is 2, 3 and 6. These are the first 3 factors except 1 of 54. Okay. So you should be clear about the question and its solution. Now let's take 1 or 2 questions of multiples. Now let's write the first 5 multiples of number 7. Okay. First 5 multiples of 7. So how would we start? It's 7 into 1. It's 7. 7 into 2 is 14. 7 into 3 is 21. 7 into 4 is 28. 7 into 5 is 35. So these are the first 5 multiples of 7. 7, 14, 21, 28 and 35. Now I would ask you one question. Which is the smallest multiple of 7? The smallest multiple of 7 is the number 7 itself. Okay. Now, which is the biggest multiple of 7? Kids, we cannot calculate the biggest multiple since this series of number is infinite. So we cannot calculate the biggest multiple of 7. Okay. And in all, how many multiples of 7 will be there? Still we cannot calculate since this series is infinite, or we can say unlimited numbers are there. So we cannot calculate the biggest multiple and the number of multiples of not even 7 but of any number. Okay. So I hope you are clear. And suppose I ask you, what is the fourth multiple of 7? So it is 7 into 4, 28. Okay. Now let's see some new concepts of the session. Friends, do you know what are odd numbers and even numbers? Odd numbers, the numbers ending with 1, 3, 5, 7 or 9 are odd numbers, and the numbers ending with 2, 4, 6, 8 or 0 are even numbers. Suppose I take an example, maybe 2, 3, 4, 5. This number is ending in 5, and the number which are ending in 5 are odd numbers. Okay, as we can see over here. So doesn't matter how many digits are there, you just have to concentrate upon the unit digit. So this is the unit digit in this number, and this is 5, and the number which are ending in 5 are odd numbers. Let's take one more example. 768. The unit digit is 8 over here, and the numbers which are ending in 8 or the number which are having unit digit as 8 are even numbers. Okay, so 2, 4, 6, 8 or 0, if they are at the units place, then the number will be even number. Okay, now let's see this 3, 5, 7, 2. Just see the unit digit, it is 2. So it will be an even number. Doesn't matter how many digits are there in the number. Okay. If it is 1, 3, 5, 7, 9. Just see the unit digit, it's 9. So it will be an odd number. Okay. Now I take some examples and let's try to find out whether the given examples are of odd numbers or even numbers. Suppose I have a number 27851. Just tell me whether this number is even or odd. Just see the unit digit, it is 1, so the number will be odd. Okay, now let's take the next example 57893. Further, just see the unit digit, which is 3 over here. So further the number will be odd. Okay. Now, suppose I have a number 72867. Further, just see the unit digit. It is 7. That means this number will also be odd. Okay. Now, let's take the next example 27984. Now see the unit digit, it is 4, so it will be an even number. Okay, let's take one more example 7285326. Okay, see the unit digit, it is 6, so it will be an even number. Further, the numbers ending with 1, 3, 5, 7 or 9 are odd numbers, and the numbers ending with 2, 4, 6, 8 or 0 are even numbers. Ending means the number which is at the units place, or we can say the unit digit. If the unit digit is 1, 3, 5, 7 or 9, then the numbers will be odd numbers. And if the unit digits are either of 2, 4, 6, 8 or 0, then the numbers will be even numbers. Okay, I'm sure you are clear about the concept of odd and even numbers. Now let's take the prime and composite numbers. Now let's discuss about prime and composite numbers. Now what are prime numbers? Suppose I have a number p. Okay, now p is said to be prime if it has exactly two distinct factors, that is number 1 and the number itself. The factors should be distinct, or we can say different from each other. Suppose I have an example of 2. There are only two factors of 2. That is 1 and 2. Okay. Similarly, I take example of 3. There are only two factors of 3, that is 1 and 3. Okay, and both of them are different from each other, isn't it? And how many factors are there of 5? It's 1 and 5 only. Now what I mean over here about number of factors, see there are two factors of 5. That means you speak the table, you won't be getting 5 anywhere else except the table of 1 and 5. So 1 into 5 is 5 and 5 into 1 is 5. You won't be getting 5 in any other numbers table. Okay, that means a number is said to be prime if it has exactly two factors. Okay, similarly we can take the examples of 7, 11, 13, 17, 19, 23, 29, 31 and more than that. Okay, so all of these numbers are having exactly two factors. Okay, say 23 is having exactly two factors, 1 and 23 itself. Okay, let's do an activity and we try to find out the number of prime numbers from 1 to 100. Okay, before that let's discuss the composite number. Now let's see what are composite numbers. Let A be a number. A is said to be composite if it has at least 3 distinct factors. That means all the numbers which are not prime are known to be composite numbers. Okay, except 1. Now suppose I take an example of 3. 3 is having two factors, that is 1 and 3. Okay. Now let's take the example of 4. 4 is having 1, 2 and 4 as factors. That means 4 is having more than 2 factors. That means 3 is prime number but 4 is composite number. I take one more example, say 8. So let's try to find out the factors of 8. It is 1, 2, 4 and 8. That means 8 is having more than 2 factors. That means 8 is a composite number. Now let's see number 13. 13 is having only 2 factors, that is 1 and 13. That means 13 is not coming in any other numbers table except 1 and 13. That means 13 is a prime number. Now let's see of maybe 10. So what are the factors of 10? It's 1, 2, 5 and 10. That means 10 is having more than 2 factors. That means 10 is a composite number. Okay. So I hope you are clear about the difference between prime and composite number. So the numbers which are having at least 3 factors are composite number, and the numbers which are having exactly 2 factors are prime numbers. Okay. Now here some important points are there. Kids, 1 is neither prime nor composite. Okay. And 2 is the only even prime number. Okay. Apart from 2, all prime numbers are odd numbers. Okay. Number which are not prime are composite except 1. That means every number is either prime or composite except number 1, as number 1 is neither a prime nor a composite. And the smallest composite number is 4. That means the smallest number which is having at least 3 factors is number 4. Okay. So I hope you are clear. Kids, now let's do an activity to find out the numbers of prime numbers and composite numbers from 1 to 100. Okay. Now the very first step is just cancel out 1, as it is not a prime or a composite. Just circle 1. Now let's begin with 2. Now 2 is a prime number, so leave it as it is and circle all its multiples. Okay, so it's 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Then 42, 44, 46, 48, 50, 52, 54, 56, 58, 60. Okay, 62, 64, 66, 68, 70. Then 72, 74, 76, 78 and 80. Okay. Now 82, 84, 86, 88 and 90. 92, 94, 96, 98 and 100. Okay, so we have circled all the numbers which are multiple of 2 or which are coming in the table of 2. So all of these numbers are composite numbers. Now let's take the multiples of 3. Leave 3 as it is and circle all its multiples. So it's 9, so it's 9, 12 is already there, then 15, 18 is already there, then 21, 3 8s are 24, which is already there, then 3 9s are 27, then 30 is already there. Every third number will be multiple of 3, so it's 33, then 36, then 39, 40, 41, 42 is already there, then 43, 44, 45 will be multiple of 3, then 48 is already there, then 1, 2, 3, 51 will be multiple of 3, then 1, 2, 3, 54 will be multiple of 3, 55, 56, 57, further it will be multiple of 3, then 1, 2, 3, 60 will be multiple of 3, then 61, 62, 63 is multiple of 3, further 1, 2, 3, 66 is multiple of 3, then 1, 2, 3, 69 is multiple of 3, then 1, 2, 3, 72 is multiple of 3, then 1, 2, 3, 75 is multiple of 3, then further 1, 2, 3, 78 is multiple of 3, further 1, 2, 3, I'm just counting every third number, okay? 1, 2, 3, 84 is multiple of 3, then 1, 2, 3, 87 is multiple of 3, 1, 2, 3, 90 is multiple of 3, then 1, 2, 3, 93 is multiple of 3, 1, 2, 3, 96 is multiple of 3, then 1, 2, 3. 99 is multiple of 3. So we have circled all the numbers which are multiple of 2 and 3, and we are not considering the case of number 1. Okay. Now the next prime number is number 5. Now let's circle all the numbers which are multiple of 5. Okay. So it's 5 and leave 5 as it is. So it's 10, which is already circled, then 15, 20, then 25. Okay, just a moment. It's 25, then 30, then the fifth number from 30 is 35, then fifth number from 35 is 40, which is already circled, then 45, then 50, then the next number is 55, then 60, then the next number is 65, and then 70, then the next number is 75, and then 80, and the next number is 85, and 90, and 95, and 100. Now we have circled all the numbers which are multiple of 2 or 3 or 5. Now the next prime number is 7. Let's circle all the numbers which are multiple of 7. So we have to circle every seventh number from 7. So it's 1, 2, 3, 4, 5, 6, 7. 14 is already circled. Now the seventh number is 21, which is also circled. 1, 2, 3, 4, 5, 6, 7. 28 is already circled. Then 1, 2, 3, 4, 5, 6, 7. 35 is already circled. So 1, 2, 3, 4, 5, 6, 7. 42 is already circled. 1, 2, 3, 4, 5, 6, 7. So 49 is multiple of 7. Okay. So let's circle it. Then 1, 2, 3, 4, 5, 6, 7. 56 is already circled. 1, 2, 3, 4, 5, 6, 7. 63 is already circled. 1, 2, 3, 4, 5, 6, 7. 70 is already circled. Now 1, 2, 3, 4, 5, 6, 7. So 77 is multiple of 7. Then 1, 2, 3, 4, 5, 6, 7. 84 is already circled. Then 1, 2, 3, 4, 5, 6, 7. 91 is multiple of 7. Now 1, 2, 3, 4, 5, 6, 7. 98 is multiple of 7 and it is already circled. Now we have circled all the multiples of 2, 3, 5 and 7. Okay. Now all the numbers which are circled are composite numbers. Okay. All the numbers which are circled are composite numbers and all the numbers which are not circled are prime numbers except number 1. We are not taking the case of number 1 since it is neither prime nor composite. Okay. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. All of these are prime numbers. Okay. Now various questions are asked about prime numbers. Okay. Now the very first question which I would like to ask you is how many prime numbers from 1 to 100. So you can count the numbers which are not circled, and in all there are 25 numbers which are not circled in this chart. So there are 25 prime numbers from 1 to 100. Okay. Now the next question is how many one-digit prime numbers are there? So these are 2, 3, 5 and 7. So 4 one-digit prime numbers are there. Okay. Now how many two-digit prime numbers are there? Friends, in all from 1 to 100, 25 prime numbers are there, and from 25 the 4 numbers are one-digit prime numbers. So 21 numbers are two-digit prime numbers. Okay. So 21 two-digit prime numbers from 1 to 100. Okay. So I hope you are clear with the concept of prime and composite number. Friends, will be taking the divisibility test in our next session. Till then, do revise this session and be clear about the concept of even, odd, prime numbers and composite numbers. Okay. Bye-bye.